Namaste to all. Today my topic is relation and function. This is from class 12 and I will start exercise 1.2. So question 1 to 7 already we have learned. So now I will start from the question number 8. So it is defined, let A and B be set so that F such that A cross B, that is Cartesian product of A cross B, tends to B cross A, such that F of A comma B is equal to B comma A is bijective function. Bijective means you have to show whether it is 1 1 or on 2. Okay, so solution, given that F such that what A cross B to B cross A is defined by F of A comma B is equal to B comma A. For 1 1, let we can consider two elements, that is A1 comma B1 and A2 comma B2 in the Cartesian product A cross B, such that in such a way we can take what F of A1 comma B1 is equal to F of A2 comma B2. So already is defined F of AB is equal to B comma A. So from here what you get B1 comma A1, and here what you get B1 B2 comma A2. We know two ordered pair, these are ordered pair. Two ordered pair are equal when if B1 is equal to B2 and A1 is equal to A2, that is B1 equal to B2 and A1 equal to A2. As a whole, what can you say? A1 is equal to A1 equal to B1 and A2 equal to B2. So here F of A1 B1 is equal to what? A1 B1, and F of A2 B2 is equal to what? A2 B2. So from that arrangement you can say what? F is 1 1. Clear? Okay, next on to. So let I consider a element B comma A from the codomain, that is B cross A, that is the second set, that is B comma A, B cross A. So B any element. Okay, then there exists another element, suppose A comma B in the domain, that is and the what A cross B, such that F of A comma B is equal to B comma A. It is obvious because already it is given F of A comma B is equal to B comma A. So here what you get, F of A comma B is equal to B comma A, and this is in the what codomain. So therefore you can say F is onto according to the definition of what onto function. So here what you get, F is 1 1 and onto. So hence F is bijective. Clear? Means if a function is 1 1 or onto, then it is bijective. Clear? Okay. Now the question number 9. It is given F such that natural number to natural number be defined by F of n is equal to n plus 1 by 2 if n is odd and n by 2 if n is even for all natural numbers. Okay, small n belongs to capital N. State whether the function is what F is bijective or not. So justify your answer. Okay, you have to justify. So bijective means already we have learned what bijective means if a function is 1 1 or onto. Okay, you have to remember the definition. Okay, so given that okay F such that what natural number to natural number defined by F of n if n plus 1 by 2, if n is odd then you will get n plus 1 by 2, if n is even you will get n by 2. So now for 1 1, so I put one natural number, suppose 1, F of 1. So if n is means one odd number, so according to the function if n is odd then you will get n plus 1. So 1 plus 1 by 2 as a whole what you get 1. If you take 2 means if n is even, so 2 by 2 you get what 1. So here what you get F1 is equal to F2, but whether 1 is equal to 2, no, 1 is not equal to 2. So from this you can say F is not on, F is not 1 1. Clear? Okay, now for onto. Okay, so let consider a natural number. Let us consider a natural number, that is n, in the codomain. So we consider a natural number in the codomain. Okay, so there are two cases, n is odd and n is even. So for n, when n is odd, So if n is odd, you can express this n in what? Twice r plus 1. A odd number can be expressed what? Twice r plus 1. Okay, for some r belongs to n. So we consider this element in the what? Codomain. Then there exists what? There exists another natural number, that is another odd number, that is 4r plus 1 in what? In the domain, such that f of this, f of 4r plus 1, whether it is equal to this twice r plus 1. Let's see. Okay, so here you get f of 4r plus 1. So it is a what? Odd number. According to definition, if n is odd, you get what? N plus 1. So 4r plus 1 by 2. So 4r plus what we get here? 2 means twice r plus 1. So here what you get? If you take in an odd number from the codomain, whether it is equal to domain, f of that number, f of 4r plus 1 is equal to this. So here if it is equal to this, okay, so for that case you can say what? For this case f is onto. But another case is there, whether if n is even, what can we say? So n is even, so next we can consider when n is even. So we can express n, that is the even number, in terms of what? 2 into r for some r belongs to natural number. Then there exists what? Another natural number, that is 4r in the domain, such that whether this 4r, f of 4r is equal to twice r or not. So here 4r is even according to definition. If n is even, then what you get? N by 2. So 4r by 2, if you cancel this, what you get? Twice r. So as a whole you can say f is onto. Okay, here what you get? What you get? F is onto. Hence f is not bijective function. Why it is not bijective? Because in the f is not 1 1 but onto. So f is not a bijective function. Clear? Okay, next question is given, question number 10. Let a equal to r minus 3 and b equal to r minus 1. Consider the function f a to b defined by f of x, x minus 2 divided by x minus 3. If f, whether you have to verify whether f is 1 or onto. Justify, you have to justify whether it is 1 or onto. So solution, okay, so it is given what? Given that a is defined by what? R minus 3 and b is r minus 1. Okay, and f such that a to b defined by what? F of x is equal to what? X minus 2 divided by x minus 3. So for onto, whether it is onto or not, verify. Okay, so let two element, let x1 comma y1 belongs to set A for in the domain. Okay, first element is domain, second element is codomain. Okay, so in such a way such that f of x is equal to f of y. Okay, now f of x equal to, it is given x minus 2 divided by x minus 3, and f of y, so you have to put in the place of x y minus 2 divided by y minus 3. So now you calculate this, take cross multiplication, x minus 2 into y minus 3 and x minus 3 into what? Y minus 2. Now you multiply this x into y, xy minus thrice x minus 2y minus 6, 2 3s are 6. Then here also you get xy minus 2x minus thrice y plus minus plus 3 3s are 6. So you can cancel the same number in both sides. This is same, this is also same. Okay, now you take the same number in the same side. So thrice x minus twice x, and here minus thrice y. So this will be plus, and here also this will be plus. So as a whole you get minus x, here also minus y. Finally you get x equal to y. So from that, in this case, what can we say? So f is what? 1 1. So here we get what? F is for on to, now on to. Okay, so let y belongs to B. Okay, so let y belongs to B. Okay, so you can express this what? Now f of x is equal to what? You can write this y. Okay, so f of x means what? X minus 2 x minus 3 divided equal to y. Now you express this what? You can express this x in terms of y. Okay, so simplify this, what you get? X minus 2 and y into x minus 3. Okay, x minus 2, here what you get? Yx minus 3y. Okay, so finally what you get? X minus yx is equal to 2 minus 3y. So if you take x common, 1 minus y is equal to 2 minus 3y. Finally you get x equal to what? 2 minus 3y divided by 1 minus y. So this is you get. So thus you can say what? For any small y belongs to B, then there exists what? 2 minus 3y divided by 1 minus y belongs to A, such that f of this 2 minus 3y divided by 1 minus y is equal to, this is 2 minus 3y divided by 1 minus y minus 2, and 2 minus 3y divided by 1 minus y minus 3. So from here what you get? 2 minus 3y minus 2 into 1 minus y, and here 2 minus 3y minus 3 into 1 minus y, and these two are cancelled. Okay, by taking LCM, finally you get this, and simplify this. 2 minus 3y, 2 minus plus twice y, 2 minus thrice y minus 3 minus plus 3y. So these two are cancelled, here these two are cancelled. Finally what you get? Finally you get minus y divided by minus 1 as a whole. Finally you get y. So if you take y belongs to B, and now there exists another number, this is in the A, and which is f of this, which is equal to y. So finally what can we say? Therefore f is onto, hence function f is 1 1 and 1 2. Clear? Okay, so the next question I will discuss in the next class. Thank you. Okay, please subscribe my channel, and if you like my video, then put one like. Thank you very much.